You ready?
Let's do it.
Ready?
All right. Good afternoon, everybody. And I'm not even going to make you say it back, but if you want to, you can. I'm Ron Miller from TechCrunch, and we're going to be discussing machine learning here today and some practical applications of it, actually. And if there are startups out there, I'm hoping that some of the discussion that we have will be helpful to you by learning from the experience that these three companies have had, building their own machine learning projects. And machine learning really seems to be at peak hype right now, but these guys are doing some really interesting projects to both fuel their operations and improve their software, and that's what we're going to be talking about today. First of all, I want them to briefly introduce themselves, and then we'll jump into it.
All right. Hi, everybody. I'm Ilia. I'm one of the founders and the CTO of Blue Apron. So we deliver all of the recipes and fresh ingredients you need to cook delicious dinners at home every week.
I'm Fred Sadaghinani. I'm the CTO of Sift Science. We're in the business of protecting online merchants from various types of fraud and abuse, protecting over 6,000 websites.
And I'm Will, CTO and co-founder of Box.com. We are an online wholesale club, and we're membership free with two-day shipping. We sell a lot of toilet paper and paper towels.
All right. Well, on that note, before we get started, to give us a baseline, what I wanted these guys to do is very briefly, maybe in a minute or less, to describe their projects. And then once you're understanding what they're doing, then we'll jump into how they kind of built those projects and what they used to do that and those kinds of things. So why don't you start this time?
Yeah, OK. So at Box, like I said, we sell a lot of your daily essentials. And one of the common cases I think we use machine learning for is your product recommendation. So based on your behavior on the site and what we know about you, we'll surface to you the brand and the products that you have a high affinity to. We also, on the back end for our logistics, we also do inventory forecasting. So basically, we try to predict how much inventory we need based on demand and historicals. The project that I'm most excited about for machine learning is also doing the flip side of that for our customers. So right now, we're trying to predict when our customers about to run out of, say, your ketchup, your paper towels, your toilet paper, and hit them with the email and make it very, very easy for them to reorder those things and stock up on the daily essentials. And we're also piloting something, what we call autonomous shopping concept with our B2B partners. So these are our businesses that we partner with, and we take it one step further, and not only do we predict using the same models, but we'll basically send them their boxes and their shipments without them having to engage with the website or the app. And we also combine that with our personalization, so you have your restock items, and you have your discovery items and your personalized sort of shipment for these partners. So we're piloting that concept out now. And that's a lot of exciting stuff that we're doing. That's the one that I'm most excited about.
So as I was saying, Sift Science, we're in the business of protecting merchants from fraud. That's everything from stolen credit cards, stolen identities, account takeover, card testing, fake content, promotion misuse. And the core of that is actually a machine learning engine. So the way we work is we're API-based, and our customers instrument their products to send signal to Sift Science, and we use that data to build behavioral profiles for good and bad users. The core challenge we have is that fraudsters are adversarial, and there's this really big class imbalance between good and bad users. That is that 1 or less than 1% of these fraudsters, these bad actors, are ruining everything for all the good people out there. So from a machine learning perspective, the core challenges we have to deal with are this class imbalance and this really diverse data set.
Great. So at Blue Apron, machine learning is something that we use in a number of areas to drive marketing and supply chain, outbound logistics, but it's really something that evolved for us out of necessity. When we started, we had a relatively limited set of recipes that we were offering customers, but we would never repeat those recipes in a year. So that was a completely different set of ingredients that we had to be purchasing each week. And as we grew our offering, the lead time on all of these ingredients required us to work increasingly directly with farms to create supply because we couldn't find it through natural channels. And so today we're working with farmers to plan their crops in advance and grow food that we ultimately send to our customers. And our traditional models couldn't scale with the number of recipes that we were offering customers each week and forecasting. So we formed a small team to create some machine learning models to determine, based off of the 4 years of data that we've collected about customer ordering behavior, their dietary preferences, things that they like, to determine many weeks in advance what they're going to be ordering in a given week, so we can place those orders ahead of time and be able to fit better recommendations with people.
Yeah, so those are great projects that you guys are working on. So I want to start by asking you, like, how difficult was it to set up, especially your initial machine learning projects, and what were some of your biggest challenges, getting going? When did you start?
Yeah, so for us to start, it was a relatively small team. This is kind of why I was excited about this panel, is because machine learning is something that has a lot of hype and mysticism surrounding it. And to get started, very small companies are now able to get machine learning models out. Like, you don't need a Google or Facebook sized team to do it. We started with one PhD and another engineer that got started on our model, and it took them about a month to get something that was roughly functioning. And then as the months progressed, it became increasingly accurate, where we started cutting over from our traditional model, and we use this model now to predominantly drive our ordering decisions each week.
Right.
Yeah, it's a very similar experience to Ilia. I mean, when we started, we implemented a very simple naive Bayes model. We had one customer at the time, and so their data was streaming in. That was actually Airbnb, and we were able to successfully surface for them fraud, and then very quickly started to acquire more and more merchants. And one of the unique things about how Sift uses machine learning is we aggregate and pool data from across the network of merchants. So a very quick challenge we encountered was dealing with the scale and the diversity. Our APIs are seeing many thousands of events per second describing transactions and posts being written and reservations being made and accounts being created. And so the machine learning models we have aren't offline small models. They're very large online systems that have to represent a very broad class of different kinds of activities. And so that was the problem that we ran into. That's the scale and investment we made.
Yeah, we started sort of looking at machine learning last year when we first hired our first data scientist. We got started fairly quickly. He got, it only took him maybe 6 weeks to start out with an initial model for our product recommendation system. We still have a pretty small team, smaller than I would like, but able to do a lot of great things with a lot of the technologies that are open source, leaning on a lot of the research that some of these AI researchers have done. Some of the challenges are really around sort of, one, really identifying kind of what problems are machine learning problems. So not every problem is a machine learning problem. Some things can be solved with a few basic rules. And really sort of understanding and sifting through your data and collecting your data in a very clean way. So some of the challenges that we have were just sort of knowing, looking at the right stuff and applying it to the right problems.
So when you say you were looking for the right stuff and to apply machine learning, was there like a trial and error period where you were working with the data and some seemed like it would have been good but it wasn't, and was that kind of?
Yeah, I think it's always an ongoing process as you try to make your models better and better, and you always want to have a sort of understanding of what your customer is doing, and I don't think it ever really stops. I think you're always trying to iterate and learn and collect new types of information from your customer that might be relevant to what the problem you're trying to solve.
How about you guys? What was it like in terms of?
Yeah, I mean, there are always things that will throw you curveballs. I mean, we have weather events that will change ordering behavior. There's a lot of seasonality to our businesses. There are people cooking, so in the summertime, if they go on vacation, holidays fall at different times in the year. So we need to be able to put these guardrails in place for the model to be able to be trained accurately to forecast what people are going to be ordering every week. And then on top of that, we'll have certain recipes that really throw a week out of whack. So for example, in one of our first years of operation, we put a enchilada on our vegetarian menu. And we saw this exodus of customers from our meat and fish menu to this enchilada recipe. And it caused a real supply chain scramble for us to get these ingredients in time.
That's too good, huh?
Yeah, and so even today we refer to it as the enchilada factor. Like any Mexican recipe will drive a ton of demand. Same thing, there are other something like melted cheese or something will somehow drive a lot of demand, and the model is able to find a lot of these patterns.
For food.
But yeah, there's always somewhat of a human element that needs to be incorporated as well.
Okay.
Yeah, and similarly for us, I mean, we're protecting merchants from many different types of abuse, but that type of abuse for a given merchant may look very different for another merchant. And so we actually have on order of thousands, if not tens of thousands of machine learning models we build for our prediction tasks. And there's a lot of complexity in the nature of the specific business. And so we're constantly having to evaluate and test and go back and iterate over the models that we've built. And it's just this really big kind of investment and an ongoing task for us.
So I was at this conference last week. It was on artificial intelligence, machine learning, robotics, and there was an MIT professor who works on this stuff at this MIT CSAIL, which is the department where they're working on machine learning inside of MIT, and he pointed out that training algorithms is not a trivial matter. There was an article in the New York Times that came through my Twitter feed the other day. There was something like, people are working to train algorithms to take your job or something like that. And I thought back to this guy's, statements that, he's an MIT professor. He's working with some of the smartest people in the world, and he finds that training algorithms is a huge challenge. So, what has that process been like for your teams? I mean, it's all well and good to talk about how you're doing this, but when the rubber hits the road, how hard is it to actually train those algorithms to do what you want them to do and to produce that information that matters?
Yeah, I mean, you need a lot of data for one. So, like I mentioned, we have 4 years of all of this customer order history, and so I mean, the great thing about machine learning is that it's not so much about intuition, but it's really just looking at all the attributes that you lay out. So we have our user attributes, we have our recipe attributes, and it will run down every possible path to find these patterns that you couldn't naturally find. And so, by design, machine learning is designed to kind of find the ruts, and so you need a lot of data to be able to run it through, because if you don't, you're going to have one outlier that's going to swing your whole set.
Right. The enchiladas.
Yeah, exactly. The enchiladas will throw it off. And then you can find the enchilada pattern, and then just put enchiladas on the menu every week, and you're all set.
Yeah, I agree with Ilia. I think the machine learning algorithms, they're all known. They're all accessible through, many different kinds of libraries like scikit-learn. They're all published in academia. There's no secret sauce there. The real challenge is the infrastructure and dealing with the data and the scale. And for Sift Science in particular, being live on 6,000 websites, seeing all these different behaviors in real time, learning online, we have a lot of challenges in building our models, and that's the muscle we've built, is being able to deploy these models that are well known and understood, and we talk about them all the time, but apply them at scale and make them work in a way that fits with the needs of these businesses.
How about you, Will?
Yeah, so similarly, yeah, it's really just about getting as much data as you can. And so for us, we did that data gathering process fairly early on, from collecting our customer data to sort of what they're ordering and their sort of how they respond to certain things, how they respond to our marketing, how they respond to impressions on our website. So everything is just funneled into our data warehouse so that we can later do processing on. So even before we embarked on using machine learning to solve some of our problems, we had already in mind that we needed to collect a lot of data, and so that really paid off for us.
So that's the data problem is an interesting problem, right? I mean, you guys seem to have been down the road in terms of your startups when you started to think about machine learning instead of building a product that had machine learning in it. If there are startups, except for you.
Yeah.
So if you're a company, and this probably is the best question for you, if you're a company that doesn't have a lot of data to start with, and you need the data to make the machine learning algorithms more accurate, it's kind of a chicken and egg thing, How do you do that?
Yeah, it absolutely is a chicken and egg problem. I mean, for us, we were very lucky in the early days. So Sift is about 6 years old, and about 6 years ago, there weren't a lot of tools and APIs available to do machine learning as readily as those that exist today. And what we built was just a really elegant API over a naive Bayes model. It's a very simple model to implement. You can implement it in a couple lines of code, and we were able to get traction with Airbnb and then slowly start to scale that out and then slowly increase the sophistication of our approach and invest deeper and further and further. And I mean, it took time, right? The data is king. With the current sets of algorithms and the approaches to the prediction tasks and machine learning today, data is king. All the algorithms, you can get TensorFlow, you can get Scikit, you can use Spark MLlib. Like, there's no secrets there.
Right. So one of the things we talked about when we had our phone call last week to discuss this panel was build versus buy. You know, and it sounds like you built. Well, we haven't discussed tools, but maybe you guys could discuss a little bit the build versus buy question when it comes to machine learning and how your companies came to the decision to do what you did, whatever it was that you did.
Yeah, so I think you're always, at some point, at some level, you're leveraging someone else's technology for the most part, right? So whether it's a algorithm that a researcher put out, or an open source library, or even these pre-trained APIs that are available through Google or Amazon or some of these other independent companies. So where really are you leveraging that technology? And I think for us at Box, we actually are a customer of Sift. So that's a great example, right? Because we don't have sort of the domain expertise they do for fraud, and so going into that decision, it's very similar to a build versus buy for a solution that's not necessarily machine learning based, right? So do you have the core competency? Is this something that you want to maintain on your own? Is this something that you'll need the agility to kind of fine tune all those models and iterate on? And so I would. That's how we sort of made our decision. So we knew that sort of like product recommendations and these sort of auto-replenish models was very, very core to our business. Whereas fraud, maybe something we know a little bit about, but we rather rely on some of the experts. So it's very similar in how you think about building versus buying in a traditional technology sense.
Yeah, to build on Will's point, I mean, you buy something that's, if there's an aspect of your business that is not unique,
right,
and you build for areas that are unique. I mean, if you have a traditional e-commerce business where you sell widgets and then you look at your par levels of the widget and you need to replenish, then there are solutions out there with ERPs that will do that. In our scenario, there wasn't software out there for where you have a handful of very limited SKUs each week that don't repeat.
Right.
And so you need to use attributes under these SKUs that they share with the previous recipes to find those patterns, and that's why we decided to build.
Yeah. I think if you think about the cloud, you have everything from small startups to large enterprises moving their infrastructure to AWS and all the other providers out there. Nobody wants to run CPUs, network, disks. It's a solved problem, and it's not a problem that's really core to the business. I think similarly with machine learning, we're going to see that the DNA in understanding the math, in running the servers, in running the infrastructure, in managing the data is going to be something for which we want a solution that we can use. And I think that's the direction that we should go in, because right now, there aren't that many experts on machine learning. There aren't that many kinds of go-to solutions, and we need to build those so that we can empower the market and the industry at scale. Right now, it's all diffused across a whole bunch of small companies trying different things, and I'm really excited about the future where there can be that killer solution that everyone can use at scale with the data and doing it in a principled, accurate way.
Yeah, I was talking about that this morning with voice interface. You have Alexa, you have Siri, you have Google, you have Cortana, and at some point we have to just sort of get a base level of functionality, and then everybody builds on top of that, and it'll be a lot simpler. This is going by way too fast, and we only have a couple of minutes left, and I haven't hit everything I wanted to, but let's do one last question. I was talking to someone here yesterday, and he was saying machine learning algorithms only get you so far, right? That the humans involved need to understand their data, right? They can't just like set it and forget it. They have to understand what's going on in their company. So what role do you guys see humans have beyond the initial training in the project and, obviously building to get down and dirty in the data and know what that means to your company?
Yeah, I mean, the human element's really important. I mean, I think 2 weeks ago they were talking about how Garry Kasparov, this chess champion, was finally able to beat this machine learning like IBM Deep Blue at chess by teaming up with the computer. And so every time the computer was beating him, but the human-computer combo was unstoppable. And so I think it's the same thing. I mean, you see like Pandora and Spotify, they have their algorithms that are determining what to listen to, but there's always a human element having that editorial piece where they're weaving in what's new and what's interesting, those kind of like trendsetters. And it's no different for us, where we have a really strong culinary team that we've assembled, and we don't intend to replace them with machines. We intend to use the machines to help them create better recipes that are better fits for people and help them discover new things. And so we always want to weave in that element of discovery.
Right. Good.
Yeah, I agree with Ilia. I think. I'm sorry?
I said quickly, we only have a minute.
Yeah, just very quickly, I totally agree. I think human feedback is critical in the loop of improving and increasing the accuracy of machine learning. Without humans, we wouldn't be able to build the models that we do. They're just kind of the unsung heroes of this process because they go and give the feedback necessary to augment and increase that accuracy. This notion of like Skynet is kind of sensationalizing what's going on in the world. The reality is that the domain experience and the knowledge that humans bring are critical to the success of these algorithms.
Yeah.
30 seconds.
Yeah, so I like to think of it as a way machine learning kind of enables humans to be smarter and make smarter decisions. I think one quick example is like, I think the program is called AlphaGo, I think, and it beat like a world champion Go player. I don't really play Go, but from what I understand, it's a pretty complex game. And the other champions that are watching the machine make moves noticed that they were sort of very, very erratic moves, but later made sense. And the conclusion that they made was, wow, this is going to really help me improve my game because this machine like maybe figured out some strategic patterns that they never thought about. So I like to think about machine learning as complementing human intelligence.
Yeah.
All right, let's give these guys a hand. Thanks, guys.